Hi guys, and welcome to Graphing Any Rational Equation where m is less than n. So if you recall from some of the previous videos, when we talk about this m and n, m is the exponent of the variables in the numerator of your rational equation, and n is the exponent of the variable on the denominator of your equation. So for example, in this equation right here that we have, the numerator, it doesn't have a variable with an exponent, and so the exponent would then be 0. Okay, and then the exponent down here, it's the largest exponent. This happens to be the only one, but the exponent is 2, and since 2 is larger than 0, that means our m is less than our n, and so we can use the specific set of criteria that we've talked about earlier. Okay, so this is from the previous example where we looked at just kind of how to analyze these equations. So remember, for the x-intercepts are where the numerator equals 0, and since 3 never equals 0, that means there are no x-intercepts. The vertical asymptote, that is where the denominator equals 0, and again, here we have x squared plus 2. If that was equal to 0, if you subtracted 2 from both sides, you'd end up with x squared equals negative 2, but that can't be true because nothing squared can equal a negative number. So there's also no vertical asymptote. And then any equation where m is less than n, so that's where this comes in, any equation where m is less than n has a horizontal asymptote of y equals 0. And y equals 0 is the x-axis, okay? So y equals 0 is just this line right along here, and we draw in our lovely little dotted asymptote just to kind of help us with creating our graph. Okay, so from there, you just need to pick a couple of x's. And so since we don't have a vertical asymptote, you can pick pretty much whichever kinds of x's you want. I always like to go just right in the middle. So negative 2, negative 1, 0, 1, and 2. And so what you're going to do from there is just plug them into the equation. Okay, so if we plug in negative 2, you have negative 2 squared is 4, and 4 plus 2 is 6. So 3 divided by 6 is 1/2. So when x is negative 2, y is 1/2. Okay, and same thing, you're going to plug the rest of these in. When you plug negative 1 in, you end up getting 3 over 3, which would give you positive 1. When you plug 0 in, you end up getting 3 over 2, which is 1 and 1/2. And then it's going to be symmetric here. So when you plug in positive 1, you're going to get 1 again. And when you plug in positive 2, you're going to get 1/2 again. Okay, so here are your values, and then from here, all you do is you're just going to plot these values. Okay, so we're going to go ahead and we're going to plot, so negative 2 comma 1/2, so we go to the left 2 here and up about 1/2, so that puts us about right there. Negative 1, 1 puts us about here. 0 comma 1.5 puts us about here. And then we're symmetric again, so we've got 1, 1, and then 2 comma 1/2. Okay, so we've got kind of this little hump thing going on. And then remember, when we're drawing our curve, what we do is we just kind of draw a curve through our points, and then it's going to keep going down towards the asymptote without ever actually crossing it. So it just kind of comes down over here, and same thing on the other side. Okay, we have our nice curve through the points, and then it just keeps going down through the asymptote without ever actually crossing it. And that's it.